afternoon, everybody. Thank you for joining us for the second rounds of this year. For those of you with us here today, just a reminder that the OEH hike is coming up on Sunday, and if you haven't already signed up to participate, there's still lots of room for more people, so please consider attending. I'm very happy to introduce Paul van Westendorp today. I actually came across Paul's name when I was reading an article on the honeybee collapse problem that's being observed across the world, and I thought it would be really interesting to have an actual expert on this topic come in and give us a valid, solid scientific opinion, because there is a lot of information floating around out there, and I know that we need somebody's opinion who we can trust. Paul, I think we can trust. He has a very long experience working with bees. He's been working with them since he was a little kid. He did all of his training here at UBC, so he's an alma mater, and he's been working with bees in a provincial capacity for 20 years now, 25 years now, 30 years now. And he is the provincial apiculturalist. So he's got folks working with him through the summers, and I'm sure he'll tell us a little bit about his job and more about this important topic. So thank you very much, Paul, for joining us.
Thank you very much. Everyone is familiar with bees and beekeeping and pollination and all these wonderful things? Oh, it is. So, well, then I can cut back a lot of my presentation, really. I would like to talk because about an issue that what Sarah just mentioned that seems to be quite under discussion, and it has a lot to do with the environment and with how we deal with pests in agriculture. And this is to do with the collective group of insecticides called the neonicotinoids. And also in the news there has been a lot of talk about colony collapse disorder, or CCD. And there has also been a lot of talk about pollinator declines, and pollinators in the broad sense. Pollinators are those creatures that help plants to complete their sex life, because plants have the liability of not being able to move from point A to point B. So they need a little bit of help to consummate the sexual act, so to say. Okay? So, in order to do that, over eons, they have developed in close relationship with a number of other organisms, and the vast majority, but not exclusively, but the vast majority are insects that are pollinating these plants, the flowering plants. This is a good example of the European honeybee, Apis mellifera, and this particular bee was also introduced to the Americas while it is not native or not represented here in the Americas at all. So this is an introduced species. We have furthermore a whole bunch of other kinds of insect pollinators. As you can see, a beautiful halictid bee, highly metallic bee, a leaf cutter bee. We have here also a mining bee, nice and fuzzy, and there we have no bee at all. It's a surfeit fly. Those guys that often float in front of a flower and stand still, and then suddenly it moves around and it stands still again. None of you have ever seen that? It's time to start observing these small things in the world around you. And then here we have a wonderful native species of bumblebee that is found here in Western North America. There are approximately 35 species of bumblebees in Western North America. We have also other pollinators, such as in the Oceania, you have in Australia and in New Zealand, you have a lot of birds that do the pollinating. In the tropics, you have, most of the hardwoods are pollinated by flying foxes, for example. But again, if you add them all up, the vast majority are bees or pollinators. So this is a collective name for all these pollinators. So what is the problem? The problem started in the year 2000 when there were increased bee losses, and I'm referring now primarily about honeybee losses in Europe and North America since about 2000. And then particularly in the fall of 2000, things started to really unravel. In North America, there were American beekeepers were reporting losses, unexplained losses of thousands and thousands of colonies. Of colonies that were apparently healthy. They didn't show any particular sign of disease. And suddenly they started to lose these colonies in large numbers. And that was dubbed colony collapse disorder. And disorder is not a disease, it's merely a phenomenon. If it is a disease, we will know what the cause of it is. But in this case, we didn't. And since that time, an enormous amount of research has been done, and we still do not know what the precise causes are of CCD. There was also further reports, many reports, not just in North America and Europe, but in other parts of the world as well, where we also see a decline in both the quantity as well as the quality, if you will, of insect pollinators. Meaning that you have a decline in the actual abundance of bee populations, but also in the species diversity in many habitats. And this is very worrisome because you could argue that pollinators, since they play such a critical role in the whole business of reproduction of plants, that if the pollinators are starting to decline, basically the environment is telling us we are in trouble. This is so-called the proverbial canary in the coal mine situation. So the colony losses in Europe were started to develop seriously in 2001, and again there were apparently healthy colonies that were started to dwindle, and it was not apparent at the time, but they were often and closely located near corn and potato plantings. Why is that significant to mention? Is that neither corn nor potato plants are important for bees to visit. They're not interested. Why? Because neither one of those plants provide a valuable food source to bees. And bees are very wise in their energy consumption, in their activity. If it doesn't provide them a food source or a food value, why bother? Okay, to visit. We are very wasteful in our energy, but they are not. As you know, bees and the bee societies, the bee colonies are all female. And they're very conscientious in the way how they consume energy. If it takes 10 units of energy to collect a food source, but the food value is only 8, you have a net loss. Won't happen. So bees are very accurate in their measurement as to when they do things. So here, there were these large colony losses near plantings of both potato and corn. And that was followed by similar reports in other parts of Europe. And this was the first time when there was a link, a suspected link, between the use of neonicotinoid pesticides and bee declines. Again, this was only a claim made, not substantiated. This resulted in massive research efforts both in Europe and North America to find out, well, is there such a correlation? And here it gets nicely confusing. There were no clear indications that there was any bee poisoning as a result of the use of neonicotinoids. However, there seemed to have been at a later point some possible links, and I will get back to that shortly. I should also mention that because there was never an explanation given about CCD, about the colony collapse disorder phenomenon, a lot of researchers, as well as beekeepers and people in that field, started to claim that there was a correlation or that it was synonymous. In other words, that the neonicotinoid effect and the decline of bees was the same as CCD. I should stress that has not been proven at all. It could be, but it has not been proven at this point. So you should consider this to be distinctly separate, the neonicotinoids and the CCD. And I don't want to spend too much time on CCD because then I'll be talking for a couple of hours. However, neonicotinoids themselves, as the name would also suggest, they are deriving the name from nicotine. And nicotine actually has been used as an insecticide since the French Revolution. Not that the French had anything to do with this nicotine, but in any way, it goes back quite a few hundred years. It's very effective, a broad spectrum, meaning all kinds of bugs are going to be killed by it. But it is typical to such a naturally occurring substance that it breaks down in the environment very rapidly. And so there is no persistence. And that is very undesirable if you're in the business of producing and making or manufacturing insecticides. Although it would be nice, because in that case you have to sell more of the stuff, but farmers wouldn't like that, because you knock down the bug, but the bug shakes its head, and then shortly thereafter it will fly off again, or it will continue to chew on what it is, on your crop or whatever. So what you need is something that is like it, very effective, but that it keeps the bug down or kills it. So our pharmaceutical industries, largely headed by Shell and Bayer at the time in the 1980s, started to develop a whole family of new insecticides called the neonicotinoids. And that with the aim that they were more stable and persistent. And the particular characteristics, I will go into that in the detail here, they are very highly toxic to insects while having a relatively low mammalian toxicity. That is making it very, very attractive. And as a result, it started to become registered in the 1990s, not merely in agriculture, but in lots of other uses. Nowadays, if you go to your pet store or to your veterinarian probably, and you want to get your flea collar for your lovely cat, it may well contain some neonicotinoids as well, because it has this exceptionally, this low mammalian toxicity. It has been so successful that now it is registered in over 120 countries in the world, and many different formulations are now marketed, and everybody is using it to heart's content. So, and these are the three major, but it is not exclusively, but these are the three major formulations that have been commercialized. The mode of action, they are typically nerve toxins. Like so many of these insecticides, they disrupt the nerve system of insects, but the key thing here is it affects the central nervous system. So the degree of damage that is created onto this insect is far greater than it affects mammals, because in mammals it is merely affecting the peripheral nervous system. And it is partly due to our blood-brain barrier that we have as mammals. When an insect is exposed to it, of course, the nervous system is overstimulated. You have the insect getting into the jitters. You may have seen that in the past. And then eventually it dies of exhaustion, first through paralysis and then followed by death. When it was introduced in British Columbia in the early or in the mid-1990s, it was primarily used as a foliar application in tree fruits in the Okanagan. And apparently there was no problems with the bees. Now I have to qualify this a little bit. In the 1990s, or in 1990, we had the introduction of a very serious pathogen that was introduced to Canada and to British Columbia, which is a parasitic mite. It's called the Varroa mite. And the Varroa mite has caused incredible devastation in any area in the world where Varroa was introduced to honeybees. Okay, this is an ectoparasitic mite that lives on the outside of the bee and parasitizes on the adults as well as on the brood of bees, and basically drinks the hemolymph, or feeds on the hemolymph or the blood of insects, of the bee. It's host specific, and it is an obligate parasite. You would think that due to such a highly unstable host parasitic relationship that we could get a handle on this particular pest easily. Unfortunately, it's not. It is a very sophisticated bug that is very difficult to control, because we have developed all kinds of chemicals to control Varroa mites very effectively, but the vast majority of those chemicals also result in the death of the bee, or sometimes even the beekeeper if we are not careful. So that is what makes it so difficult to find something injurious to the mite and not injurious to bees or the beekeeper. So this whole period was coinciding with Varroa mites as well that caused a lot of damage. So our ability to really measure whether or not these foliar applications of neonicotinoids, the effect that they had on our bees, we don't really know. We assumed that there was no problem, but maybe all the problems that arose in the Okanagan, let's say in the 1990s, could well have been associated with foliar applications of neonicotinoids. Since the early 2000s, the use has been broadened. The manufacturers have gone through a number of generations of these neonicotinoids. And the key component here is that they have focused or have directed this group of insects to be systemics. and systemics versus foliar application, meaning that they are absorbed by the plant and is taken up in very small dosages. And as soon as you come by as a munching insect and you want to feed on the crop, that you get ill because you're taking small amounts of neonicotinoids in your system, and you either croak or you stop eating and you go hungry or you stop reproducing and all these other things. And here you can see the wide range of crops for which this has now been registered. Very low dosages absorbed by the plant, and then these feeding insects or sucking insects, and those are controlled or killed. The drawback is, of course, is that the plant material itself has this in its tissue. And we sometimes eat that tissue. Of course, these are crops. But I will get to that a bit later. So the introduction of these systemic insecticides happen to be coinciding with the pollinator declines. Now, it is incredibly tempting then to conclude, rather prematurely, that, since it coincides with the introduction of these neonicotinoids, it's got to be the neonicotinoids that are responsible for the pollinator declines. And with coming back onto the corn and the potato planting deal, nowadays when a farmer calls the seed company and say, I need so many tons of corn seed for planting corn, it's automatically being treated with the neonicotinoid as a seed treatment to protect that very vulnerable little seedling when it emerges against all kinds of feeding insects. It's very handy. It's a kind of an insurance policy, right? So, works really well. But with the application of some of these seeds, you have dust that comes from these coated seeds that can often have very high concentrations of the active ingredient. The other problem is also the repeated applications. You have 1 year corn, the other year you have some other crop, and all of these are maybe treated, and by the end of the result with all this persistence, you may have a buildup of residues in the soil. We haven't thought about that too much, but that is what the result of it is. So when in year 4, because of crop rotation techniques, you may have some wonderful clover growing in that field. I'm just saying something. And clover is, of course, highly attractive to bees. Maybe all these little clover seedlings will absorb these residues as well, and will end up in the pollen or in the nectar and everything else, and that is brought into the hive or into the solitary bees that are there, the wild bees, and they may all be croaking. Or the populations may be reduced. As I said earlier, the systemics are very persistent in the soil with potential for soil residue buildup. This has a real problem also, what I said in the 4th year, that you have a non-target crop, a crop where basically they had not planted or placed any of these neonicotinoids in it, they may end up being poisoned as well. So all of these studies now, or in the past, on assessing the toxicity to any of these insecticides were often done using acute exposure studies. Tinekes is a toxicologist in Europe who came out with a paper in 2010 which really put everything a little bit upside down on this whole discussion. He said that so far all these pesticide assessment studies were flawed by only measuring them either in the laboratory or simply measuring them on the basis of acute toxicity. And he said, look, the way we should really assess the whole impact of these family of these sophisticated products is by measuring it according to chronic exposure at sublethal levels. Now try to think of that, chronic exposure at sublethal levels. So these are levels that are so low that the bug doesn't die, but it is being exposed to it all the time in a sublethal environment, slightly poisoned environment. And then you may have all kinds of unexpected results. Even at levels, look at this, if this lethal dose may be of a certain amount, they have even at sublethal levels can be as low as 6,000 times less. But that may still have a serious impact on these insects. There's another worry as well, that some of these products may well have a significant interaction with existing chemicals that are in the environment. either man-made or naturally occurring materials. There may also be certain environmental conditions that cause these insecticides to become more effective or having a greater impact. So what could possibly be the impact on pollinators at this sublethal chronic level? Well, here are some of them. Behavioral changes, for example, less of floral fidelity. Floral fidelity is critical in the whole biological scheme of things. What that means is this, that if a honeybee or a solitary bee, there are hundreds and hundreds of solitary bees. In fact, North America has about 3,000 different species of bees. Okay. All kinds of bees. The vast majority are solitary bees. It's just dear mama who's trying to provision a little nest. That's all what she does. And after mating, and she has done all this stuff, she dies. I see in your mind, well, what about the males? Well, the males only come out when they're born. They quickly mate, and then they croak, generally speaking. Okay? So bees are really female. All of it is female. They are the keys to all of this. Floral fidelity, and I don't mean that the quality of fidelity is inherent to the female rather than to the male, but that's a whole other discussion. But the fidelity means this, that if a bee, being solitary or social, will go to a dandelion, and it gets its food, part of its food, and carries these pollens on her hairy body, it doesn't go from there to an apple flower or to some other blueberry flower. If you do that, the whole business of pollination is lost. Because the apple flower cannot do anything with the pollen from the dandelion. They cannot mate, they cannot cross, they cannot... Huh? So what the whole idea behind fidelity is that the bee goes to the next dandelion flower. And she keeps on going to this particular floral source until these floral sources start to diminish in their abundance. And there may then be something else that pops up and becomes more abundant, and she may just adjust, or she or all of the bees in a colony may adjust and start foraging on a new food source. In fact, that is one of the reasons why in blueberries, and all of you eat now a lot of blueberries because they have told us good with antioxidants and all kinds of other things, right? So it has blossomed into a massive industry here in the Fraser Valley. Over 22,000 acres of blueberries are now cultivated in the Fraser Valley alone. So we recommend blueberry growers not to put in the honeybee colonies that they rent from beekeepers until there is about 20% bloom. Because if they put it in too early, there's still too many dandelions in the area. And dandelions are far nicer for the bees to fly on, and they prefer that. These girls are picky. And they don't want to give up that food source, right? So they keep on flying on dandelion, and that is not what the blueberry grower wants because he pays for the bees to be in his field. So, floral fidelity. Well, with the impact of neonicotinoids, you may have a decline in this behavior of floral fidelity. Reduced homing ability. If a bee flies around out there, she doesn't do it from some innate satisfaction. She does it to provide food for the nest, be it her singular nest or for the colony. If she loses the ability to fly home because she scratches her head at one point somewhere in the field, where did that come from? I'm lost. It's like you park your car somewhere in a big parking lot and you say, what? Huh? You can waste a lot of energy finding your home back. Okay? That is disastrous. We have now, it has been noticed that it sounds interesting, but we call it premature dementia, that these bees lose the ability to learn and to memorize things when they are exposed to these sublethal levels at chronic levels of the neonicotinoids. Impaired communication. Bees they communicate with each other. Not the solitary bees, but the bees in colony talk to each other. Not verbally, but through a whole other system of communication. Largely olfactory, they have scent, they use pheromones in order to taste, you might say, impulses, as well as through a particular dance that they have where they can tell each other, you have to go to this and this and this direction, and you fly so many miles, and there you find a good food source. Okay? They communicate with each other. Well, if you lose that, you have a bunch of gals sitting together not knowing where they have to go. It's a problem. Reduced capabilities. This is particularly noticeable, of course, in solitary bees, because in honeybees you have one individual, the queen, that is responsible for the egg laying, and she will never come out of the hive during the times of egg laying anyway, so she is quite insulated and farther removed from any exposure. But particularly with solitary bee populations, that is a very serious problem if they have reduction in reproductive capabilities. And there's also now quite some scientific information to indicate that exposure to neonicotinoids also reduces disease resistance in bees. So, what is the current status of this? And there is still an enormous amount of confusion involved with it, with the neonicotinoids, is that there is now the European Union, European countries became sufficiently concerned about this that they placed temporary bans on some of the formulations. And demand is first to be that science first has to prove that these neonicotinoids do not have the damage that they are suspected of creating. Health Canada became also concerned, and in June of 2012 it made the announcement that it wished to reassess the 3 major formulations in these neonicotinoids. The EPA, the Environmental Protection Agency in the United States, also came up in December 2012 and decided basically to do the same thing as what PMRA decided earlier. And then the European Union made a very bold decision, and they imposed the so-called precautionary principle of the registration of any new neonicotinoid formulations. And the precautionary principle, of course, says that up to, prior to that, basically some preliminary studies would say, well, these things are pretty okay. And that is why PMRA, the Pest Management Regulatory Agency responsible for the registration of farm chemicals in Canada, and the EPA in the United States say, well, it looks like the profiles are quite okay. You can register, you can start using it, and in the meantime, you use it until we can prove that, well, there is some problem with it. So there is widespread use in these things. Now, in Europe, they've said, no, we're not going to do that anymore. What we're going to do is now, if you want, as Bayer or whoever it is that produces this, if you want to have your magic potion registered for use in agriculture, you first have to prove that they do not cause the damage that they are suspected of doing. So that is the precautionary principle, which is a huge step. Here in North America, we have not gone that far yet, and we still allow for some of these products to continue used until the research shows otherwise. EPA also just announced recently to have demanded changes to the label instructions in order to protect bees better. So what's the future on this whole neonicotinoid business? Well, I don't know, because I don't know what the future will bring. However, you can expect that if there is an increased demand for this precautionary principle, that it is going to be very costly and very time-consuming for these companies to do that, with the potential that they may also say, oh, that's not healthy, it's not worth it. So they will withdraw some of these formulations, or proposed formulations. Now, that opens up a Pandora box of problems too. Because would that mean then that the farming community would go back into the organophosphates and the organochlorines and all these carbamates? This whole generation of chemical groups are what we call the hard chemicals. These are the real nasty ones that we have worked so hard of getting rid of. Right? So we don't know what is going to happen. What is also another thing what you would probably be interested in knowing, and I like to emphasize this, and the marketing of pesticides have changed quite considerably over the years. I mentioned earlier about the seed treatment thing, that farmer picks up the phone and calls and says, hey, I need so many tons of seed, and it is already automatically treated. What we haven't gotten into is this business of applying it regardless. Preventative, it sounds so wonderful, you know? Prophylactically. Expensive name. But what it means is that you basically stimulate chronic usage, indiscriminate usage. And in beekeepers meetings, when we have also beekeepers using a variety of products to control mites and things like that, we with the Ministry of Agriculture very strongly say, look, do not use anything in your beehives prophylactically. And to challenge them, I often say in a meeting from, hey, who is out here taking any antibiotics? Just for the possibility to prevent maybe a bladder infection in the future. Oh, by the way, does anybody take antibiotics out here? Just to be on the safe side? Of course not. But we do. In many production systems, we do. And sooner or later, the problem with it is, sooner or later, nature will take care of this irresponsible behavior by creating a bug or a pathogen that is called resistant. And so what do? We cook up some other chemical that is either stronger or nastier, or the typical reaction of the farmer is, let's put an extra spoonful in for good measure. Okay? So this whole business, marketing of, and I don't want to blame this all on the manufacturers, by the way, but of course you can imagine if you are a shareholder, you like this. You know, more earnings. And Bayer, by the way, the principal manufacturer of neonicotinoids, has made billions over the last 10 to 20 years on the sale of just these neonicotinoids. It's the most successful group of insecticides ever produced. And it is a very big concern because a whole bunch of specialists in my generation have spent decades advocating and promoting IPM, which stands for Integrated Pest Management. And that means you do not apply something automatically, but you first take sound measurements to see, do I need to use it or not? All of you must have heard of the Colorado potato beetle. No? God, you guys are all too young. This devastated potato crops in many countries. Beautiful beetle, by the way. Gorgeous. But it was master in chewing up potato plants. Okay? And in the 70s, I mean, the typical field that you would find in apple or in potato fields is the farmer spraying 3-4 times, big boom, and spraying these hard chemicals, such as the organophosphates and the organochlorines and all those. Today you don't. Because nowadays you're likely to find one of your fellow students at UBC walking around, underpaid and all, in a dusty field with a swoop nest or a net in the middle of the field and looking at it and putting her or his head in it and counting bugs. And you count bugs by determining the ratio between the pest insect and the predatory insects. And if that ratio is okay, the farmers won't spray until there are not enough predators and too many pest individuals in your net. Then, and only then, the farmer will start spraying. It is an integrated pest management system. What does it require? Knowledge, labor, even cheap labor, but labor nonetheless. It's kind of inconvenient. You know, this thing is so much easier. It's just, yeah, you give me the truck, we'll spray, right? And here you can use uneducated labor to be exposed to the chemicals. It costs a little bit more, but nothing compared to the educated level. And you can do it on a timetable. June the 1st, oh yeah, well, we might as well order the stuff and get going. You don't need anything more. And that is a real problem in big agriculture nowadays. And of course the environmental impact of all this use, of this chronic use, is something serious that we have to get our heads around in as a society. You know, humans have been responsible for the creation of some 80,000 man-made chemicals. 80,000. And I'm sure that the vast majority were not intended to ever end up in the environment. But they are still in our biosphere. Somewhere, sooner or later, something comes out. You have all heard about paint containing lead, which we all splattered on before you were even born. And now suddenly everybody is starting to worry about it. Or suddenly, I mean, for some time. What about asbestos? What about all kinds of chemicals? It's naive to think that these things simply are miraculously disappear. They're somewhere. And sooner or later they will pop up in a form that we mostly don't like. So the environmental impact of some of these products ought to be considered far more seriously rather than how much they offer on the bottom line of a corporation. I started out by talking about the wonders of pollination, and although this is a lily plant, here you can see the various components where here you have the pollen grains sitting here, and they ultimately will have to be transported here to the stigma, and from there they will grow through the style out here into the vessel that at the bottom contains the ovules or the eggs. And the easiest thing as an example for that is when you have an apple. You cut open the apple in the middle and you see the apple with beautiful dark reddish colored seeds. That is the culmination of a successful pollination. If you have an apple with a small cheek and a big cheek, that is mostly a sign of an incomplete pollination. And there you have mostly that the ovules remain milky in color, okay? Uncolored. This is the good example of incomplete pollination. Guess what? That doesn't help the bottom line to the farmer. This is what they all want. Even color, even seeding, or even development, even size, even everything, high sugar content, the whole shebang. That can only be accomplished with the visitation of a bee. A bee, not necessarily honeybee. There is a lot of emphasis, of course, on honeybees, and the reason is that honeybees are by far the most successful in agricultural settings. Although bees themselves, honeybees, are not that good at some floral sources. There are some other bees. Let's say in blueberries, bumblebees are far better at it because they co-evolved over millions of years with those bog plants like blueberries and cranberries. Honeybees developed in a more semi-tropical environment. These are generalists. Bumblebees are very focused on a number of plants such as blueberry and cranberry. What's the difference? Well, they have, for example, a buzzing behavior. What they do is they clamp onto the flower and they contract and relax their flight muscles very rapidly without moving their wings. And you can hear them. And as a result, this very sticky, wet pollen is liberated from the pollen source and sticks immediately onto the hair of this hairy bumblebee. Also, because of the wings going so rapidly through the air, they build up a slight static electricity. So when that powdery stuff comes off, it clings right away onto the hair. That is very effective for them to go to the next flower for pollinating the next flower. But there is an increased dependency on honeybees, and the reason for that is because of what I mentioned earlier. As wild pollinator declines, there is a sharp increase in a lot of crops that require bee pollination, and that is partly because also and high yield varieties that are being developed. For example, you can often hear about having a romantic picnic under the apple tree in the orchard. Well, nowadays you won't find those anymore unless you have some very old orchard. You go into the Okanagan. Do you know how they grow apples today? Like vines on grapes. They have them all along trellises. Because now the pickers don't have to stand on a ladder. They can just pick them all up to a height of 6-7 feet. That's it. High density. But that high density is nice, but bees behave totally different in these tunnel and in these rows compared to having an open parasol type of orchard. Bees behave differently. And our tendency to be picky ourselves. We like the fresh blueberries. We like the kiwis. We like the rambutans or the lychees or the whatever, and mangoes at any time of the year. Our demands on the environment in terms of foodstuffs is extraordinary. Unsustainable, by the way, but then we are only a small section of the entire world population, so we can, I suppose, afford it. But that requires enormous environmental inputs. So the amount of bees that are required for all of this have increased enormously. Here in British Columbia, if you just assess the value in dollars and cents, about $200 million worth of crops are produced in British Columbia each year that are insect pollination or honeybee pollination dependent. I put here also tomato simply because it is a very successful crop in greenhouses. But as you can see, these are strictly bumblebees. Honeybees are long-distance flyers. They don't tolerate the confined space of a greenhouse. They like to fly out. And tomato plants are not that nice for them because they only produce a little bit of pollen, and honeybees are not interested. They like the nectar as well. Bumblebees are less discerning. They don't mind that. They don't mind the confinement of a greenhouse, and they have inside of their little their caged or their nest, they have a small source of nectar placed in a bladder and a carbohydrate source, and they're happy with the tomato plants. But they do a marvelous job out there. Without it, you will not have tomatoes. In Canada, the estimated value is about $1.5 billion a year in agricultural production, and in the United States, because of their warmer climates, not because they're Americans, they produce well over $15 billion. You may have seen the program by Dan Rather half a year ago. Most of you probably don't even know who Dan Rather is. Anyway, a very well-known, famous anchorman in CBS for decades. But he retired about 10 years ago. But he still does special things, special programs. And this had to do with the very precarious circumstance of the most successful and most lucrative cash crop of California, which are almonds. California produces 80 to 90% of the almond crop for the world. In February, all these beautiful trees come into their pink blossom, but there are no bees anywhere. It's void of bees. So hundreds of thousands of colonies are brought in from different parts of the United States to satisfy the pollination needs of this particular crop. But the United States beekeepers have been suffering from all these losses of bees, and therefore the price has been going up and up and up and up. And this last spring it was very precarious. There was a situation where perhaps there were simply not enough bees to meet this crop. And that is threatening. It is only a signal that there are more of those problems going to happen in the future. Worldwide, it is a kind of a wild guess, but it is estimated to be well over $220 billion worth of agricultural production that is dependent on bees, not just honeybees, other kinds of bees also. This is just a quick, simple example of some of these crops that we have out here, and some of them that are also produced in the tropics, because you like to start your day at Starbucks out here, but guess where that happens? Somewhere in the tropics, somebody had to visit that flower and get the coffee bean pollinated. This is a little bit, I perhaps should take these out, because again, what I mentioned earlier, these are pollinated primarily by flying foxes, but some bees are also involved with some of these tropical fruits. You may also notice here cotton, and next time you are going to to Buckerfields or whatever and get your veggie garden going next spring, guess where those seeds come from? That grower had to get some bees in order to produce these plants to produce seeds. It doesn't all happen by itself. Alfalfa and clover, we don't get into the habit of eating those, but all of our meat products, such as cows and pigs and all this other stuff, are highly dependent on these particular crops. Okay? Canola, one of the most successful crops in Canada, produced and developed, bred by, selected by Agriculture Canada researchers in the 1960s. Do you know this rapeseed is what it used to be called? There were only 2 countries in the world that produced it, India and Poland. And now Canada is by far the largest producer of it, creating a $1 billion industry. There are thousands of colonies being rented under contract by hybrid canola seed producers in southern Alberta each year, just to make sure that they produce enough seed. That is the reason why we have to be concerned, because we can't manage without them. I made it. Any question? No question.
Thank you very much, Paul. I'm sure there's many, many questions. I'll hand the mic around if people put their hands up.
There is somebody there.
Yeah.
I was interested that the nicotinoids are cholinesterase inhibitors, and the alternatives, the prior alternatives, organophosphates and carbamates, are also the same. And is it just, I'm just curious that we didn't see the same problem if those things were used before. Anyway, are there subtle differences in the type of inhibition or the strength or, yeah?
I would think that the main difference is the fact that the neonicotinoids display an extraordinarily low mammalian toxicity, and that has what made them so attractive. While all the organophosphates and organochlorines and whatever also displayed extremely high toxic effects upon humans, or on mammals in general. The neonicotinoids are so attractive for the reason that they are so safe for us to use and to be perhaps a little bit exposed to. Now, I'm not a toxicologist, so don't challenge me too hard on that because I just don't know. But you can call Bayer and they will tell you.
I wasn't aware that bees were rented out, so I'm just wondering if you could give a little bit of an explanation about that, and I'm just wondering too if this is being used as a strategy to manage a lot of the bee deaths, or if the bee deaths are occurring in the rented bees as well, or because I guess I just always thought that it was the natural bee population that was at risk. So
excellent question, because it generates a whole bunch of points. And cut me off if my answer is a little bit too long, or answers are too long. You point out a good thing. We have, because of our incessant demands on high quality foods, we've got into the business of monocultural practices. So many miles by so many miles of nothing but one crop, which is environmentally a totally unsustainable situation. So we have to put in an awful lot of resources, not just chemicals or fertilizers or whatever, but also things such as bees in order to make it possible for these plants to produce their fruit or their seed or whatever we are after. When growers have these miles of nothing but the same stuff, they cannot rely on the natural population. And it is a good example. I mentioned coffee. I used to live in East Africa where I worked also on bees, and we dealt there with the Africanized bees, or also known as killer bees, but that is a different thing. The coffee, the Kenyan coffee, all of you must have tasted that lovely coffee. And because we acquired here in the Western world for such a fantastic taste and preference for Kenyan coffee, we started to buy more, and as a result, they enlarged their acreage to produce more coffee. And then they discovered, geez, in these central parts of these larger fields, the coffee set or the fruit set was very poor. And nobody had ever really addressed the issue before that indeed you need bees to do the sexual act for the plants. And as a result, now they had to start introducing bees in order to make sure that this was also properly pollinated. If you go into the Central Valley, you can drive for miles and miles and miles and miles, tens of miles, of seeing nothing but almond crops. There are no bees in February in California, at least in that area. So you have to have your pollinator introduced. Unfortunately, unfortunately, there are not many choices. The only bee that can be brought in sufficient numbers on demand are honeybees. And for that, of course, you have commercial operations. You have beekeeping operations out there that run 5,000, 10,000, 20,000. I think the largest is about 30,000 colonies. So they are big operations. This is not a mom-pop operation where you put on a couple of hives in the back of the truck and you go out there. We have those as well here in British Columbia, but it's a commercial enterprise. It is an bona fide agricultural enterprise. Okay. So they pay for that. If you don't, a farmer is not obligated to buy or to rent these colonies, but the result of it is that you will have a much lower fruit set, if not a failure in your crop. So it is and the pollination income is an integral part of commercial beekeeping. Beekeepers today cannot live off just the sale of honey. Because honey, particularly here in North America, we consider honey just merely as a fancy sweetener. In Europe, Or let's say in Africa you cannot even get a wife without having a significant amount of honey as a dowry payment. Yeah. So honey is really valued in many parts of the world, but not in North America. It's like fancy sweetener.
A question from our online audience. I'll hand it over to Lydia here. Oh, I'm going to take the one from our online audience and then give it to you. Craig Olenberger asks whether or not backyard hives have been suffering at the same rates as commercial hives.
That was your question as well. Yes, indeed. It is indiscriminate. And I should tell you that our program with the Ministry of Agriculture is very much focused on diseases. That is what our main thing is. Somewhat sad and negative, I suppose, but that's what we do. And without criticizing backyard beekeepers, but if you add up all the disease incidences, backyard beekeepers are often worse as beekeepers in terms of keeping diseases at bay than commercial beekeepers. Because commercial beekeepers know that it's the bottom line and they cannot afford to see too many of their colonies die because of some unforeseen circumstance. So they tend to be on top of it better. But while a lot of backyard beekeepers often get into bees because it is a lifestyle. You know, they like it because the bees are part of, makes you feel good, right? But then they don't have enough technical know-how. You recognize that, eh? Yeah, we often do these things because of the love and the interest that we have, but we are often not very practical in following it up properly. Bees, by the way, I've been around for a long time with bees, and 30 years ago, beekeeping was the most romantic, rustic, kind of lovey-dovey type of enterprise you could think of. You could almost literally put your armchair in front of the hive and commune with the bees during the summertime. And then at the end of the summer, you would open up the tap and the golden honey would flow out, right? Today, boy, you do that and your bees are dead. Now it is one of the most complex form of small animal husbandry. It's small animal husbandry. I share my life with a whole bunch of veterinarians at the office out there at the Red Barn. We call it the Red Barn in Abbotsford. It's a big red building. All these veterinarians are there also. And these guys have never really spent any time on recognizing what insects are all about. And when we have our mandatory presentations and everything else, I always like to rub it in a little bit that yes, indeed, insects are animals. And they cannot get their head around that because it doesn't have a hoof or it doesn't have hairiness or a feather or something. Okay? It belongs to the animalia. It's an animal. It's not a plant. Sorry, that was a diversion from your question, but indeed
Lydia's got another question. Thanks very much for a very interesting talk. I admit to not having paid too much attention to bees or think much about them before, but hearing this, the bees' problems could very well be my problems because I love my fruits, right? This could be another seminar topic, but I'm just curious, the matter regarding climate change and impact on life, mammals, insects, and whatnot. Can you comment on? I know with Neonicotinoids,
yes.
Neonicotinoids caught me tongue-tied with that.
Often called neonics.
Neonicotinoids. It's a totally separate issue from climate change, but yet I'm just curious. I can't help but to think whether or not there are any might there be any direct or indirect impact with climate change on bee pollination, bee colonization, etc.
Yes, and no. Bees themselves are sorry, I should first subdivide. There are a lot of solitary bee species that are highly specific in the environment in which they can survive. So you have, for example, an awful lot of soil nesters or dwellers, like mining bees. But the name also indicates they dig a hole in the ground and then they make little rooms, and then in the rooms they lay an egg and everything else, right? If you don't have the right soil type or the right conditions, humidity-wise and so on, they won't survive. So some are highly specific and sensitive, if you will, and others are very broad and more accommodating. Honeybees, in large measure also because of our human intervention, are held in the Yukon Territory, where they are kept, as well as in the tropics. So they have a huge range of adaptability. There are in the species Apis mellifera, is what we would call the European honeybee. There are about there used to be at least some 23 or 24 races or subspecies. Okay? And one of them, what I mentioned earlier, is a subspecies or a race called Apis mellifera scutellata. And Apis mellifera scutellata, is the one that was brought over by a researcher in the 1950s to South America to improve the European bee stock that was introduced to the tropics out there. And these European bees didn't do very well. Or shall I say, the races of European bees that were introduced from Europe to Sao Paulo or thereabouts. So he thought, hey, there are some other races of honeybee, European honeybee we call them, that are doing very well in the tropics, so why don't we drag it over? And so he did, and those ones are a little bit different in their behavior. And those ones escaped because they had African genes in them, and this undesirable characteristic was that they're highly defensive. They are nasty. So the result of it was that you had European bees that lived in South America that had then become Africanized. Subspecies, of course, can mate with each other. Races can mix with each other. Species difference is too far apart, they cannot mix. They cannot mate successfully. Well, they can mate, but they mostly have not viable offspring or offspring that cannot reproduce itself. Sterile offspring. Okay? So, but racial differences are not a problem. So you have now Africanized bees introduced to European bees in South America. Well, these African bees, they thought, hey, this is heaven. So they went through the Amazon, and they went on to Central America. And then the Americans started to become nervous. And then finally in 1990, they crossed the border, and they came into the United States. Beekeepers are masters in culling things. They apply selection that is extraordinarily strong, selection pressure. You know, the guy can walk into the hive, oh God, get stung, I'm going to kill that queen. Boom. All the genetic material is gone. Okay? So what is the big concern about Africanized bees in North America? Litigation. That's the problem. Okay? So here you have a farmer who rents a whole pile of colonies, and then from a beekeeper, and then it turns out that some of these colonies are Africanized bees. Oh, can you imagine a lawsuit? Fantastic. Any bee stinging incident becomes a killer bee stinging incident. And then we have all these litigation activities going on. So it isn't, from an environmental perspective, it was an extraordinary successful event, how Africanized bees spread in virgin territory. So your question probably is, I might as well ask the question first before you ask it, so what about Canada? Well, the funny thing is that the very behavior that makes them so undesirable is a very wasteful form of burning up energy. It's coming out en masse to attack something that disturbs them. Okay? But I told you that way before. You know what, bees are extraordinarily efficient in assessing the value or the economics of energy consumption. And here in the temperate zones, if you do that and you're too wasteful in your energy, guess what happens? You die in the winter. So thank God that we have cool climates, cold climates. Because Africanized bees are not expected to be able to establish themselves out here at any great length or great numbers, simply because climate will do them in. Boy, that was a diversion of the original question, but my apologies.
One more question. I'm wondering what the half-life of these neonics is as compared to the organophosphates and organocarbamates or whatever.
Well, I don't know about the organophosphates and all those other hard chemicals, but I do know that the neonicotinoids, particularly in these residual soil conditions, can last for 3 or 4 years. But again, these are at very, very minimal levels, at sub-lethal levels. And that is where the worry is, that they have this kind of insidious effect. Not an acute toxic effect, but a slight creeping kind of pseudo-toxic kind of effect, if you know what I mean. And that is the worry, and that is so difficult to measure. Cheers.
Much, Paul. That was a fascinating presentation, and last round of applause for our speaker.
You're welcome.